Sorry. Hello, everyone. You're welcome to Uhandisi Talks. My name is Marion Golda, and today I'm here with Engineer Rufaro from South Africa, a chemical engineer. She's joined us today to share with us her journey and some of the career option that you can have if you want to do chemical engineering, and some of the challenges she faced, and how she overcame them, and some of the places where someone can work if they want to be a chemical engineer. So I'm really excited. You're welcome to engineer to this live. This is Uhandisi Talks, and we'll get right into it. So you're welcome, Engineer Rufaro.
Thank you so much, Marianne. Thank you for having me.
Yeah.
Okay.
So please just let us know your background. Like, could you just please tell us your background? But before we get to your background, let's start with a short introduction: who you are, what you do, and then we'll get to your background.
Okay, sure. I'm Rufaro Mukwenya. I'm based in Cape Town, South Africa, but I'm actually from Zimbabwe, Harare, the capital. I have just recently graduated from my master's in the chemical engineering field that Marion talked about. And at the moment, I am working in research in the department that I completed my master's in, which is in biotech. So we currently specialize in using bioorganisms, microorganisms, to produce valuable products from otherwise non-valuable materials. But yes, I think that's as much as I can go to without giving up a lot of what we have in store for today's talk. But yeah, just a small little intro, yeah.
All right, thank you. I have to say, I really didn't get much of anything with the biotech and all that. So you're gonna tell us more about that later.
Oh no, definitely. I will.
Yeah. So we're gonna get about that into that, and I'm sure the chemical engineers will be watching this. They will understand better. But
Yeah.
then now let's get yeah. So now your background, like chemical engineering, like when did this start? Did you was it like a dream you had, or when did this start? When did this journey start?
Sure. So it wasn't necessarily a dream that I had. All of my secondary school, I thought I was going to be a doctor. I thought I was going to do medicine. I thought I was going to be a doctor until I actually visited the hospitals. And when I went to the ICU, I realized, you know what? I don't have the strong heart for it because I almost cried. So I can't be a doctor if I'm going to cry when I see people in pain. So then from there, I was a little bit lost. I won't lie to you. I was a bit undecided because I'd always thought I was going to do medicine. So fortunately, the school that I went to, there was a career guidance office that was tailored towards leaving high scholars. So I didn't actually think I would go to them, but then I realized that I had no plan for what I was going to do for my university. So then we sat down and we said, okay, if you can't do medicine, what else can you do? So at the core of it, I realized that what I actually like is helping people. So if I can do anything to solve problems and help people, then that would be great. I hadn't thought about engineering of any kind. I just always said, I'm going to be a doctor, I'm going to be a doctor. So that was the first breakthrough that happened. I was still, I think that was my last year of high school. But then now we needed to narrow it down. Okay, engineering, what type? So, because the conventional ones are, your mechanical, your electrical.
Yeah,
I actually hadn't heard about
exactly.
civil, actually. Hey? I hadn't heard about civil
Okay.
until I went to the career guidance. I was like, oh, okay, there's civil, etc. So we then sat down and said, okay, my strengths actually lie back then and still now, I think, maths and chemistry. Physics wasn't really my strong suit, and neither was actually bio, which is interesting since I'm now in a biotech space. But
Yeah.
so then we focused on maths and chemistry. Like, okay, let's see what we can find. And so that's when I first found out about chemical engineering. And until I started my first year, I thought chemical engineering was chemistry, which is it's the worst misconception to have about chemical engineers, because we're not all about chemistry. Yes, chemistry
Okay.
does play a factor, sorry, but we're not
Yeah.
just chemists. So it was then when we discovered what chemical engineering is and where it can be applied. So basically what a chemical engineer does is that we design,
Yeah.
develop processes that
Yeah. Yeah.
that take a raw material. As long as you have a raw material that you need to process until you get to your final product, you'll always have a chemical engineer there. So as long as it's maybe something from A to B to C all the way up to Z, as long as it's a process, then you'll find a chemical engineer. So the best way to think of us is process engineers as opposed to just chemical
Yeah.
engineers. So with that in mind, we then realized that there actually are a lot of fields that we can go into. I'm not going to go into it yet. I'm still talking about my background. But then I realized
Yeah.
that having chemical engineering as a degree wouldn't be like limiting me to just being in one field. There are actually so many areas where we can fit in as chemical engineers, but we'll talk about that later. So, okay, so chemical engineering was one of my options. The other one was biomedical engineering, because I still wanted to be in that kind of field, but then unfortunately I wasn't accepted into it.
Which
So I
field?
made because, yeah, I wasn't keen to stay in Zoom. I wanted to leave. I don't think chemical engineering was at the university that I wanted back home. So then I opted to come to South Africa. It wasn't too far from home. So yes. So when I got into, actually another Civ Eng was also my other option because it's not
What?
too much physics. Physics is there, but it's not too much.
Uh-huh.
Am I lying?
Okay.
I want to lie.
Physics is in chemical engineering, but not too much.
Yeah,
Oh,
not
were you
too
saying you
much.
had? Okay. 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 Okay.
I was asking for
So
civil engineering, is there a lot of physics in civil?
no, not much. Unless you're doing something like
Exactly.
hydraulics. I think if you're doing like hydraulics, water engineering that you get, I think if I
Okay.
remember fluid mechanics, and that the unit from campus, of course, is the thing that was closest to physics. But I think it's not really that much. Yeah.
It's not really that
So
much,
that's a
yes.
very
So
rich
that was my
background.
other option. I was like, okay.
Yeah. Yeah.
So
So it's
then,
really great you've
yes, so
taken
then
us
I decided
to,
to do.
you've even taken us. Yes.
Oh, sorry, go ahead,
Sorry.
sorry.
Please finish your thoughts. I was saying it's
Come
really
again?
great you've taken us through what I'm saying. Can you hear me? It's really great you've taken us
Yes, now I
through
can hear
what
you.
chemical engineering is, and I don't know. You've taken us through what chemical engineering is, and that you're not chemists. And it's so exciting that you also told us that you don't do one thing, like you have a series of things that you do, and it's not just like one thing. And I mean, one wouldn't expect that for chemical engineering, you know. And that's why I'm just so happy that we are having this conversation. I mean, it can help anybody right from high school, you know. If you think of chemical engineering, what is this? I mean, what am I really going to do? And I have to say, I didn't know what I was going to do in my career until I finished school. So I think this is going to be very helpful. And now you've talked about where this began and the career coaching and everything. How was your undergraduate studies? How did that go?
Okay, so initially, I remember my first year. My first year was very challenging because, first of all, being away from home, that was my first time being away from home, and then realizing how much maths is involved. Is what we actually do is we design equipment. We're part of the designing team because obviously you have your mechanical engineers and your electrical engineers making sure that the equipment that is, say for example, we want to produce B from A. So what we do is we look at, okay, what are the chemical properties of A? How does it behave as a fluid? If it's a liquid, if it's a solid, if it's a gas, how does it behave? And how is that going to influence the reactor, so the piece of the equipment that you're going to use to put A into, such that you can then create B. So all of that uses a lot of mathematical models, a lot of computational tools where you need to understand that, okay, because A is like this, if it's a liquid, it has
Yeah.
to do this. So my instrument, my reactor needs to be able to, if there's any heat that's produced or released, your reactor needs to be able to withstand all of that. So that's just a little snippet of how we come into processes in general, because you'll find that we're actually useful in different areas, different fields.
Yeah.
So that
Yeah.
was a surprise to me.
That lots of
Because
mathematics.
so basically my undergrad consisted of, sorry?
You didn't expect the lots of mathematics. You didn't expect a lot of
I did not
mathematics.
expect that.
What did you expect? Chemistry.
I didn't. I honestly, I did. I thought that
Uh,
surely there's a little bit more chemistry. No. So
uh-huh.
chemistry was only compulsory in first year. That was the only time we did
Uh-huh.
chemistry as a compulsory elective. And then maths was compulsory all the way. But another thing that I was surprised was all the teamwork. So basically, at every single semester, you're grouped with 3 or 4 different individuals. And after every
Mm-hmm.
3 weeks, so how it's structured at UCT is that 3 weeks you have a module where they're teaching you maybe, let's say, reactions, chemical reactions. And then in the
Mm-hmm.
4th week, you have a project that's centered around chemical reactions. So what they do
Mm-hmm.
in that project week is that you're grouped with 4 people, not your friends, it's it's randomized, and you
Okay.
have to work
What kind
together
of project?
to, sorry?
What kind of project were you doing?
So it would be either designing a piece of equipment that's in the process overall. So, for example, say you're trying to make coffee. You have the initial
Uh-huh.
stages where you have the plant, and then you have to grind it and
Yeah.
mill it, and then you have to
Yeah.
ABCD all the way up to. So, at that initial stage, okay, I have to design the grinder to make sure that it actually works to
Yeah.
efficiently as well, like motor power and all of that. You need to do that. So, um,
So
in doing
can I
that,
just
go ahead,
could I
go
just
on.
cut in? So you're designing
No,
the
please.
like you're saying like you guys you're designing an equipment. Somebody does themselves an equipment in chemical engineering. Where do they meet?
Where would we need equipment? Okay,
In
so
chemical
for example,
engineering.
yeah. So let's say, okay, let me talk about chemical reactions. So let's say you've had your reaction, you've had A turn into B, but then the B that's been produced now it's at such a high temperature. Now you need to cool it down to a certain. Maybe you need to cool it down to room temperature, because at high temperatures, maybe you might experience maybe the chemical compound may be either harmful or it may be volatile such that it releases fumes. So you need to, as a chemical engineer, you need to design a heat exchanger. So a heat exchanger basically makes sure that a fluid is at the right temperature that it's supposed to. If it's too hot, it cools it down. And if it's too cold, then it heats it up. So let's say in
So then
some
they
yeah.
the heat exchanger, is it an
Mm,
equipment or is it like it's an equipment? So then that
yes.
would be like mechanical engineering, or wouldn't it be?
It so we work with our mechanical engineers. So what we need
Uh-huh.
to do is to ensure that the material that's used to build this equipment is strong enough or is the right grade.
Uh-huh.
If it's stainless steel, it has to be the right grade. If it's thickness, it has to be the right thickness. If it's corrosion
Mm-hmm.
resistant, it has to be corrosion resistant. So that's what we look
Mm-hmm.
into. And then we give those kind of specs to the mechanical engineers to obviously then build it, or and then the electrical engineers then have to wire it and all of that. But then we just need to make sure
Mm-hmm.
how we come in is to make sure that it's not going to blow up. Like you start your reaction or you start whatever process and then all of a sudden nothing happens or it explodes or so we make sure that it's efficient and that it's safe, hand in hand with
Mm.
mechanical
I think
engineers. Yeah.
mm-hmm. I
So
think when we
yeah.
start talking about the thank you so much, Rufaro, for that. I think when we start
Mm,
talking about the career paths and where we are working, I think we're gonna get the picture more clearly. But
sure.
then also when you're talking about that, I thought we could add something on how where else, because you talked of you guys are working with the mechanical engineers. So maybe later when you're talking about that, you could tell us maybe if you work with other engineers, if you work with civil engineers, if you work with electrical engineers, and what it is that you guys do with other engineers. So we can look at that later. But for now, I
No
want us to
problem.
finish with the background. I
Yes,
want us
sure.
to finish with your
Yes.
background. And I've just realized you haven't told us. Did you tell us where you were working? You haven't told us where you were, the background where you worked, what kind of work you do. Um, so if you have somebody with a related question, they can be able to ask. And as you answer that, also please tell us something about the MSc you just completed and how that was. So the two questions.
Okay, that's fine. I can answer it together because I'm working as a research assistant actually, at the Center for Bioprocess Engineering. So that's a research group that's within UCT. So what I did for my MSc was how good is your science? If I say enzymes, do you know what enzymes are?
Yeah, I remember from chemistry.
Okay, perfect. Okay,
From
perfect. So
biology. From
enzymes.
biology.
Yes, nice. So
Mhm.
basically, what I did with my MSc, we there in the past 30 or 40 years, there's been this specific enzyme that was isolated from a mushroom. So what that enzyme
Mhm.
does is it produces how deep can I go? So basically, it would hey, I'm trying to make it. How good is your chemistry? If I say
I'm
oxidation,
already intrigued. I'm already intrigued because you're telling us an enzyme from a mushroom.
yes, an enzyme from a mushroom. Yeah, literally. So what they did, they
Okay.
isolated it and realized that it has certain properties um, that make it very useful when it comes to trying to turn something that's basically non-reactive into a valuable product. So if I say something like alkane, alkane, do you remember alkanes? Okay.
Nah.
Styrene. If I say styrene, styrene is like a
Oh my
chemical.
lord. That's chemistry. This is
Okay.
so deep.
How do I
You're
describe?
taking
It's
me
a
way
certain
back
chemical.
to high school.
Okay, sorry. I'm realizing. Okay, let me come back. Let me come back. So basically, if we have a chemical, a naturally
Yeah.
occurring chemical, that is definitely like it's difficult for it to react under normal circumstances. It just doesn't react. But then the thing is, you can get valuable products from it. If maybe, say, you add an oxygen to it, or you add a nitrogen to it, or you add something to. So by itself, it's very useless. But then through a
Mm-hmm.
reaction, it can become something that's
Mm-hmm.
useful, right? Valuable. So
Mm-hmm.
conventional methods, conventionally, you'd need to use catalysts. So a catalyst is something that speeds up the rate of a reaction. All right.
All right.
Okay.
I'm
Yeah.
trying to
So
get it.
okay. So traditionally, what would happen is, say you want to make an alcohol from something that's it doesn't react. So what would usually
Yeah.
be done is they would use metal type of catalyst. So that means extracting metals from the ground and then creating a catalyst such that you can get your valuable product. Because remember, catalyst speeds up a reaction. So what this enzyme
Yes.
does is that it does the same
Mm-hmm.
thing, but it does it at lower
Mm-hmm.
temperatures. So if you were to take your
Okay.
metal catalyst, you'd need like temperatures of about 100 to 200 degrees Celsius. But then what this enzyme
Okay.
does is it makes that product, but at literally room temperature. So you can
Oh my
still
God,
get
that's
your,
fascinating.
yeah,
That's
but,
amazing. And
like,
but
yeah, the problem,
you're
the
saying,
only problem, the
mhm.
main problem with using this enzyme is that after a certain time, it dies.
Okay. How long?
So it just, at some point, the chemicals become too strong for it because remember, a mushroom will be just chilling in the forest and it's just doing its job. It's in nature. It's in
Uh-huh.
its natural environment. But if we now take that
Okay.
enzyme out of the mushroom and we now put it into a more chemical environment, it becomes a little bit uncomfortable. So it will be able
All
to
right.
perform the reaction, but at a
Okay.
slower rate, and at some point it dies.
Oh,
So
uh-huh.
my thesis was seeing what conditions were optimal for me to get a high product, a high conversion.
Yeah.
So that means I needed to change the chemical environment that I was adding the enzyme into it and tracking the life of the enzyme or the activity of the life to see, okay, at
Yeah.
what point does it die? And what's the environment looking like at that point? So I would change various things like the temperature, like the pH or water or so, and in doing so tracking the life of the enzyme as well as how much product it made. And then I needed to apply a computational model to it to see,
Uh-huh.
to sort of have an understanding of the kinetics or basically the lifetime of the enzyme. So that was
Mm-hmm.
basically my entire thesis. And
Mm-hmm.
using
Okay.
that, I did that at a very small scale. And then
Mm-hmm.
the hopes were to be able to do it obviously at larger scale so that it can become a viable process, obviously, because you don't want to do this and then,
Okay.
yeah, yeah. So basically, so it was like a proof of concept type of project to see, okay, at this small scale, like I think it was 20 milliliters that I worked with, how viable
Mm-hmm.
is this process with this enzyme? Yeah.
Okay.
Yeah.
So how many mushrooms did you need?
So fortunately, fortunately, there is a company. No, actually, it's a university.
Yeah. Yeah.
University of Free State, which is in South Africa. They already do the entire extraction. So what I just needed to get from them was a little bottle that they'd already extracted, purified, and
And
packaged.
okay.
So they'd already done the first part of it.
Mm,
Yeah,
okay. Okay.
yeah.
I thought you were going to
So
look for mushrooms. I literally thought you were going to look for mushrooms in the field.
yo, that would have been exciting. I would have liked doing that. I would have
Yeah.
liked it.
Yeah.
But yeah.
That's
And then
interesting, Rufaro.
currently,
That's really
oh,
interesting.
sorry.
See, I was saying that's quite an interesting project, and I know I have very little information of what chemical engineering is, and now you're teaching us.
Mhm.
But then I find that project really interesting. Um, that you're using mushroom as a metal catalyst. I find it really interesting, and I was wondering, did you find out how long it lasts the lifetime, and if this is something, if it's scaled, because you're saying that you'd like to see it being scaled. If that happens, then how would it help in the chemical engineering field?
Sure. Okay. So I don't know if you remember my post where I said sometimes research works, sometimes it doesn't work. So
Exactly.
yeah. So it worked up until the longest that I could keep it alive was about 16 to 24 hours. And then at that
Mm-hmm.
point, it just died. So what now needs to be done? So instead of scaling it up, because obviously you don't want to scale up something that dies, that's not viable. So now what needs to happen is it's a technique called protein engineering. So
Okay.
basically, what they want to do is to maybe change the genetic makeup of the enzyme such that it can
Mm-hmm.
last longer, which is a whole other research
Mm-hmm.
project on the side that needs microbiologists. So as you can see, with my project, like in the research group that I'm in, we are chemical engineers, we are microbiologists, we are biotech specialists, we are chemists, analytical chemists. So
Mm-hmm.
right now, the research group that I'm in, it's so diverse and multidisciplinary in the sense that yes, I'm a chemical
Mm-hmm.
engineer, but some of the things
Yeah.
that I'm doing lean more to microbiology or lean more to chemistry. So, but I still
Mm-hmm.
fit in. So that just
Yeah.
shows that, yeah, with chemical engineering, there's a lot that you can do. So right now, well, actually, towards the end of the year, I'm still waiting for a new project, but towards the end of the year, the project that I worked on, so I'm more into the biotech space. So some of the
Mm-hmm.
collaborations that our research group works with involve
Mm-hmm.
pharmaceutical companies.
Mm-hmm.
So the company that I was doing research for, it's called
Mm-hmm.
Afrigen. So basically, they work
Mm-hmm.
with vaccines. So obviously, after COVID and all of that, there was a
Mm-hmm.
big rush, as in so many more African countries were now trying to produce the vaccine by themselves because otherwise, before then, vaccines. So what I needed to do in that sense, I didn't work exactly as a process engineer, like in the lab, but I worked more as a consultant. So, being a
Mm-hmm.
chemical engineer, you get equipped with so many different skills that it also involves data analysis skills. And even with the projects that we would do in undergrad, instead of
Mm-hmm.
and we didn't just design equipment, we'd also cost them. We'd also see what would be in the environmental impacts of that whole process. So we'd look at
Mm-hmm.
everything in a holistic view.
Okay.
So with
Okay.
that, and also because it's projects, so there are also project management skills that you get from doing that for 4 years,
Mm-hmm.
as well as presenting. So you
Mm-hmm.
present your findings as well every single year, twice a year at least. There's a presentation where you have to present, and it needs to make sense as well.
Yeah.
So,
Yeah.
so with those skills, there was a project
Yeah.
that we worked with this company that's called Afrigen. So basically, they were
Mm-hmm.
comparing two processes that they had developed that were developed actually like globally to see
Yeah.
which one was more economically viable than the other. And so what they wanted to
Okay.
know is if they could change a certain condition or change a certain equipment. So instead of using stainless steel reactors, they wanted to use a different type of material. And so what I needed to do
Mm-hmm.
was to see whether that would be viable, how much it would cost, and the implications of making that change and whether it's
Okay.
feasible. So
Okay.
I wasn't in the field, but what I needed to do was I um there's this so we also do computational skills are also involved here. So there's this
Mm-hmm.
modeling
You know,
software.
Rufaro,
Yeah.
you know, by the way, I have to say you are literally answering the questions I had in mind. And thank you so much, because now I'm starting to see how the engineering part is coming out. Because now you're talking about cost benefit analysis, the data analytics, and softwares and things like that. And you're starting to bring out now the picture of the engineering part of it. And when you're
Yes.
talking about the vaccines, I thought to myself, uh, I mean, you wanted to become a doctor, and that's just like medicine.
Oh,
Literally, I mean, you're doing it. You're both a doctor and an
yes.
engineer. It happened. Yeah. So,
Oh,
right?
oh wow. I hadn't thought of that. Oh my
That's what I
gosh.
thought. And I'm just saying to myself, like, all this time you've been sounding like a doctor.
Oh my
So it's
gosh,
like you
that's so
achieved both of your
amazing.
dreams. Right.
That's so amazing. I hadn't made that link yet. Wow. Thank you for sharing that
Yeah.
with me.
Yeah.
Thank you. Wow.
I just thought of that.
No, thank
And
you.
yeah, you're
Oh,
welcome. You're welcome.
mm,
So please finish your thoughts. Please finish your thought. I just wanted you to get that out.
don't even remember.
You can't remember. Okay, you were telling us about your project and the research company you're working on,
Oh,
and
yes.
your contribution, and now you started bringing us to the skills, some of the
Oh,
skills that you apply
yes.
even as yeah.
Yes, 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 yes. Thank you. Yeah, so so initially what I needed to actually do was to develop the entire flow sheet. So starting from scratch, from raw material up until final vaccine product. And then in that, hmm, should I show you this? Okay, no, it's IP protected. Sorry, I was gonna share my screen and show you what the process flow sheet looks like.
Uh-huh. You can. Is it
Fine.
I
Can
think you
I?
can present. Yeah.
Okay. Just I'm so sorry. I hadn't prepared this sooner. I should have
Uh,
had this
if you have it ready. Yeah.
readily
If you have
available,
it
but I
ready.
can I can quickly access it. Sorry, I just got really excited.
Okay. Okay.
I
No
just got really
worries.
excited. I
So
can
as you
quickly
as you
present.
get that,
Hmm.
yeah, no worries. So as you
Yeah.
get that, I'll just like to tell those who are watching right now that we are talking about chemical engineering, and Rufaro has taken us through her journey, right from how she began this, she decided to do this, and what she wanted to do initially, and how that didn't work out, and then this worked out, and her education background, and the project that she did that was really amazing. And keep watching. So, did you find it, Rufaro?
Sorry, are you still there?
Yeah, I'm still there. So this flow sheet that you're talking about, is it something that will maybe show
It's
us?
breaking up a little bit.
A, I'm sorry. I'm sorry.
Hello.
Can you hear me now?
Sorry, it's breaking up a little
Can you
bit.
hear me now?
Okay, now I can
You
hear
can
you.
you
I
hear
can
me
hear you
clearly?
properly. Sorry, I just seem to be having
Perfect.
yes. Now I can hear you. Now I
Okay.
can hear you.
Okay.
I
All right.
can
Sorry
hear
about
you
that.
now.
All right. Perfect.
Unfortunately, I'm not sure what is happening. Hi. Can you still hear me?
Are you there, Rufaro?
Yes. I don't know what's happening. I'm
I'm sorry about that. Yeah,
so sorry.
it should just be the connection. No problem. So did you find the flow sheet?
Hello.
Yeah, can you hear me, Rufaro?
I'm sorry, like there's a lot of technical difficulties happening on my end. Um,
Sorry about that. So we were waiting for you to show us the flow sheet.
I
You
don't.
mentioned
Sorry
about
about that
sharing.
to your viewers as well.
No problem, no problem. Yeah, that happens.
Um,
No problem. Yeah. Were you able to
okay,
find
can
it,
you
or
hear
are
me
you
now?
still perfectly?
It's not. It doesn't want to. It's still not working. And I think maybe that's what's
Oh,
causing. I think maybe that's actually what's causing all of this.
the whatever you're
So let
trying to
me.
share.
I'm sorry about that.
Okay,
If it is,
it's okay.
yeah,
We can continue. Yeah,
yes, it's
no problem.
causing a
Yeah.
glitch. Yeah,
Okay.
I'm so
Okay.
sorry about that. I really wanted to show you. I'm
Yeah.
so sorry. I'm so sorry.
All right. All right. No problem. Now it gives.
Yeah.
Okay. What I think we can.
Yeah. So
Yeah. Yeah. Please continue.
sorry, come again.
I'm saying continue. Just finish your thought.
Oh, okay. Okay, yes, I'm so sorry about that and for all the glitches that are happening. Sorry about that. But yes, basically, I needed to develop the entire flow sheet from scratch. And then from there is where I needed to work out what the costs were for each individual equipment as well as the raw materials
Mhm.
that were needed. So it
Yeah.
was, yeah, it was quite challenging because also I needed to present that information to back to the African representatives, as
Mhm.
well as
Mhm.
compiling a report that explains everything that I did, my research findings and conclusions and all of that.
Mhm.
So
Mhm.
it was very interesting. And I think I've been in the research space for a couple of years now, and it's made me want to sort of not stay, but I really do enjoy research. So
Okay.
applying scientific theories or concepts and actually using it in to solve problems or real application of it. So I've been enjoying it and I'm hoping to stay in that field as well as like in the pharmaceutical space. Yeah.
Mhm. Oh my Lord. Can you hear yourself?
Um,
You're literally a doctor.
but no, no, no. I was going to talk about where
I even
I was going to talk about
pharmaceutical
where chemical engineers can go.
vaccines.
No, I was gonna tell you where else chemical engineers can thrive. So besides
All
the
right. So
pharmaceuticals,
so I
biotech.
think
Yes, sorry.
Rufaro,
Yes. Mm,
before we get before we get to where chemical engineers can thrive, I think I just want us to have highlights of what we've talked about so far and take a very short break and then we'll be back. So thank you everyone
no
for
problem.
tuning in today. Okay, thank you for everyone for tuning in. I'm having with me Rufaro from South Africa, a chemical engineer, and she has shared with us her journey into chemical engineering and what she wanted to be before and how she got to chemical engineering, how undergraduate was like for her, how MSc was like for her, and where she's working now, her thesis. Like very, very, very interesting. I have to confess, I only remember the mushrooms and a metal catalyst, but I'm sure the chemical engineers that are watching have learned so, so much. So, Engineer Rufaro, thank you so much for sharing with us. So, we are going to be back in a few minutes. Stay tuned. Welcome back, everybody. I'm here with Engineer Rufaro, and we're talking about chemical engineering. So we've gone through her journey into chemical engineering, her work, her research, and we want to continue with this discussion and get into other areas. And Rufaro, I want you now to tell us a bit about the flow sheet you're talking about, and maybe we can talk about
Oh
this.
yes.
You just let it fit in, but then I want us to now continue into chemical engineering. And there is something that you said that I wanted you to expound on. You were telling us the difference between chemistry and chemical engineering, and why people should not think that chemistry is chemical engineering. So I would just love you to please expound on that, on chemistry versus chemical engineering, and what chemical engineering is really about. If somebody is thinking about venturing into this field of chemical engineering, what is it that they're going to, what is it that they're getting themselves into? So as simple as you can, so that you can be able to help even somebody who probably is from high school and hasn't really has completely no knowledge of what this is.
Okay. Um, okay, I can do that. It might be easy actually if you could share the flow sheet as well, if that's
All right.
possible.
Okay.
Yeah,
Okay.
but I can start off by saying chemistry looks at chemical compounds more at the molecular level and how chemicals interact with each other. So that's essentially what analytical chemists do, is to look into the molecular level of chemicals. But then with chemical engineering, we touch on that a little bit, but
Mhm.
essentially we
Okay.
look at how those chemical compounds
Yeah.
interact through a process stream. So we need to make
Okay.
sure that the chemical, oh yeah. Oh, okay.
Yes. Yes.
So we need what
Continue.
we okay, sure. So what we need to do is to make sure that the chemical at each section of the process, we need to understand how it behaves, how it flows, how it heats up, how it cools down, and we need to make sure that the equipment that whatever chemical is strong enough to withhold whatever is happening, whatever chemical reaction is happening in that. So it uses
Oh.
chemistry, but then it's more than chemistry. That makes sense. Yeah.
Okay.
So chemistry is
Okay.
like the people
Okay.
literally behind the scenes, making sure that looking into what the chemical reaction looks like. Okay, A plus B gives us C, but maybe A plus C also
Yeah.
gives us something else. That's chemistry.
Uh-huh.
But then we get the more bigger picture with regards to how can I get from A to Z with efficiently, safely, without causing environmental concerns and all of that. Yeah. So that I think
Yeah.
I
Yeah.
hope that will help someone understand that it's not just chemistry.
I
Yeah.
remember. I remember you mentioning you really didn't do even much of chemistry in your undergraduate. You
It's just
mentioned
it
that.
was just
Yeah.
1 year or 4 years was
Yeah.
chemistry. Everything else was just maths. Yeah. But like, so I don't know if you
Okay.
can actually share the flow sheet so that it might make a bit more sense. I hope I don't scare anyone.
Okay.
Yeah.
Huh. Let's see. Are you able to see it? Oh, perfect.
It's still loading. It's still loading on
Okay.
my
Let me
side.
know when you
Okay.
can see it. And
Okay, I can see everything. Yes, that
yeah,
looks
we're
great.
definitely scared. We're scared.
No, trust me, this is not scary. This is fun. This is so much
Uh-huh.
fun.
So what are we
I
looking at?
I honestly enjoyed creating this flow sheet. So basically, the vaccines that they were
Uh-huh.
rolling out back then, COVID, basically how you start
Yeah.
off is what what we need is something called an mRNA strain. That's just a biological
Uh-huh.
term for what the type of vaccine that's used to treat COVID. It's just something called mRNA vaccine. So how you actually produce that is,
Yeah.
oh, I'm gonna scare people here. Basically, it's a
Oh my God.
biological process. It's a biotechnological process that the pharmaceutical companies have adapted. So essentially,
Mm-hmm.
okay, we're all made up of DNA. We know that, right? DNA,
Yeah.
it's basically what makes you and me. Fine. So what happens is
Mm-hmm.
with the vaccine, they isolated a part of a DNA strand that helps um to to treat COVID. So instead of, and
Yeah.
that
Mm-hmm.
vaccine, that little small fragment that you use for the vaccine, they found a way
Yeah.
to engineer it, actually
Yeah.
to recreate it without having to look for
Yeah.
natural resources, right? So what they did manage to do is they isolated that little part, and now basically what this whole process is upscaling it. So how do you actually get DNA? It all boils down to biological processes. So something called fermentation. You know, bacteria, they are naturally occurring. You'll find a bacteria anyway, anyhow, right? Big, small, whatever. So what they have done is
Yeah.
that through something called
Yeah.
protein engineering, they've made sure they found common bacteria that grows rapidly. It's called E. coli. And they've added that little small segment into it such that when it
Mm-hmm.
replicates, you get more of that little segment that we want. So that's at the beginning. So at the beginning where we have meat, I'm not going to explain the
Mm-hmm.
entire flow sheet because it's very long, but then just the beginning where we have media flowing
Yeah.
in. So that's basically
Yeah.
the food for the bacteria that contains the vaccine that we want to then extract.
Mm-hmm.
So we first need to grow
Yeah.
it. You first need to grow your
Yeah.
bacteria. So you can't just grow it out of. So the thing is, working with living organisms is where the biotech or the bio side of chemical engineering becomes interesting because you need to treat your organisms nicely. Otherwise, it won't grow. And if it doesn't grow, then you don't have a process. So
Okay.
that's why you start off with smaller volumes at the beginning there where it says fermentation,
Mm-hmm.
fermentation. You start off with smaller volumes until you have a big enough volume where you can now extract this your what you call it? This your vaccine that you want, the mRNA strand. So essentially, every
Mm-hmm.
step of
Mm-hmm.
the way, all those little equipment pieces, we would have designed them. Everything from the mixers to we would have designed them, but not obviously by ourselves. We also need your mechanical, your electrical. So I'm always going to say this because I don't want to seem like, oh, we know no, chemical engineers do not know everything. We don't. We
Uh-huh.
work together. That's a
Yeah.
very important thing that I
Exactly.
learned throughout my chemical engineering journey is that we
Yeah.
work
Yeah.
together. We need to come together to solve problems.
Mm-hmm.
Yeah.
Yeah.
So, as
Yeah.
opposed to
That's true.
chemistry would have looked into maybe, okay, what are the chemical compounds that are going in? But now, as a chemical engineer, I'm going to look at every single piece of equipment and make sure it's heating properly, it's making sure that the mass is flowing nicely, all of those things, the fluid behavior, that it's not too thick for the stirrers, all of that we consider chemical
Mm-hmm.
engineering. So basically it starts off with just media and a little bit of bacteria and it grows. And then if you can just scroll
Okay.
to even the end, because after you've produced what you want, you now have to separate everything
Mm-hmm.
out. So that's the basically the rest of the process. If you could just scroll down to literally the end, everything after that is just, oh, you scrolled fast. Okay, yes. Everything
No,
after that is just
sorry, sorry.
separating. No, it's fine.
So actually, I
You
wanted
can
to ask you because you
go ahead.
mentioned. Can I ask something? You mentioned that this was something that this used this to develop the COVID vaccine. Was that it?
Yes, 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 yes.
So did you work on this during COVID?
No, I actually worked on this towards of the end of last year, is where they're trying to see
Then,
how to make
uh-huh.
savings. Yeah. So
Okay.
no,
Uh-huh.
unfortunately, yeah. During
So does
COVID,
it also
during
mean
COVID. Hmm. Go ahead. No, go ahead. Sorry.
So then, does it mean that you work with doctors as well? Because if you'd be working to maybe see how to make the vaccine more efficient, then you'd need input from doctors as well.
Um, in this particular project, not necessarily. It was more of the research and development team that I worked with, so R&D. So I didn't
Mm-hmm.
necessarily interact face to face with doctors, but I'm pretty sure that their input is also needed in this. Yes, you're absolutely right. Yeah, you are right. But just,
Okay.
yeah, not in this
Okay.
particular
So,
project. Yeah.
mhm.
Yeah.
Okay. So
Thank you
I
for
want I
asking.
want you to tell us. Okay. Okay. You're welcome. I want you to tell us what we are looking at, because you're telling us this is what chemical engineering is all about. Is this what a chemical engineer should expect on a day to day?
Yes, actually, yes. Because remember, you're going from raw material to final product. So as long as you're starting from A all the
Mm-hmm.
way to Z, there are certain steps that happen
Mm-hmm.
along the way. So yes, you can actually scroll down all the way. Every single step is a different equipment that you would have designed. So as long as, yeah, so we start off with a raw material, which is media at the top there, and then we end up, so after you've produced what you want, we now need to separate things out. So basically purifying. So all of this is just purification. All of these
Mm-hmm.
steps are just methods of purification up until you get to the end, almost the end, where you get your final product, which is the mRNA vaccine. So this was
Mm-hmm.
just to simulate what the process would look like based off of material that's available. Like there are so many resources that explain how the COVID vaccine is made. It is widely available.
Okay.
Even I think Pfizer, you can find it on Pfizer. You can find the patent where they actually show, okay, this is what we do from A to Z. Yeah. So first of all, I had to make this flow sheet,
Okay.
and then I had to do the actual data
Mm-hmm.
analysis that was required. Yeah, yeah.
Wow.
So
Interesting.
this was a
Very
project.
interesting.
So this is,
You
yeah,
really seem to
and
love this.
I I do, I
Yeah,
do.
I can hear how passionate you are about chemical engineering and
I
about
do.
research.
Yeah.
And you know
Yes,
why I'm
I
so
yeah.
excited about this? Yeah. And I'm so excited about this, Rufaro, because I have to share with you. I feel like this is an area that is not explored. Research by engineers
Mm,
is not really explored.
that's true.
And I've actually, this is something that I was thinking of doing, like something to just shed a light on research, but maybe we can organize for this on a later date and do that as a separate discussion so that we can
Sure.
be able to fully explore that career path in research, because I
Mm,
really feel if we don't research, then how are we going to move forward? How are we going to discover and innovate? Yeah.
mm,
So
mm.
if this is a pending discussion, we need to revisit.
Yes, definitely. Yes, that's really got me excited. Yes, yes, 100%. I really enjoy research. Yeah. So
Okay.
I'm happy to chat more about it
So
later.
mhm.
Yeah.
Oh, perfect. So before we finish with the flow chart, I want
Yeah.
you to tell us, because I'm wondering what you used to do this. There's a moment you were talking about some of the tools you use in your work. So maybe you can tell us some of the tools, and maybe you can combine it with the skills that you're talking about, like the softwares and that you're going to be
Mm,
using on your day-to-day work as a
mm,
chemical engineer.
mm. Okay, so there are different types of software that are available for different processes. So this one that I used, it's called Super Pro Designer, and it's tailored mainly for bioprocesses. So your pharmaceuticals, fertilizer, biofuels, anything that's bio related. It's called Super Pro Designer. Then another one that we used, it's called Aspen Plus. So basically, that also models more to do with separation. So that purification process that I was telling you about. So yes, you're going to produce whatever product that you're looking for, but then it's going to be in a mixture, because remember, you're adding things together and then it reacts, and then you will end up with a pool of different types of compounds, but you don't want different types of compounds. You want something that's pure. So what that software does is it helps you design what's called a distillation column, where basically you can separate compounds based on maybe their volatility. So you can maybe heat it up such that the more volatile, when I say volatile, the ones that have lower boiling points will evaporate off, and then your desired product remains, which is what you then separate out and then package. So mainly those were the main software tools that we used. Otherwise, Microsoft Excel, as you can see, this flow sheet, I've added it there. When it came to performing economic analysis, we would also just use Microsoft. But now what I've noticed is data science has become very popular. Unfortunately, I didn't do that in my time. It was only introduced recently. Like after COVID, things became more remote. So now they've added data science as a module to chemical engineers, because coding is also another thing, is also something that you can use to solve mathematical models or as a tool for that. So, which is something that I really need to work on, because that's where the world is going. And just to add on to that, once you have something like Python or MATLAB as a language that you are comfortable with, that helps you branch off not only to chemical engineering, but you can also use that in data analytics in different fields. So what's interesting is that they're actually consulting companies that strictly recruit chemical engineers. Companies like, I wrote them down, McKinsey, BCG, it's called Boston Consulting Group. They actually have bursaries that are available to undergraduate students, such that when you graduate, they want you in consulting, which when I first started, I didn't realize that you could go into consulting as a chemical engineer, because the skills that you get are transferable to so many fields that aren't necessarily chemical engineering. I have a couple of colleagues who are people that I studied with in undergrad that are working in banks. Imagine a chemical engineer in a bank, because the skills that you get.
I know. Isn't it surprising?
Yeah.
So okay. So
yeah, go ahead. Yeah.
I want us to spoil that. I don't want us to spoil that part, because I want us to discuss in a few about the places that we are going to work. But yes, the way you, as you've said, when you finish your studies, you literally didn't know you could work in some places, and I think that's what I think we really need to share such kind of information, because I went through the same thing. I think I shared with you. I went through the same thing. I didn't know where to work. I literally had no idea. And I realized that when you studying, you really don't think about these things. You just think about studying and, having fun and doing other things. And you finish and you literally don't know what to do with this qualification that you have. So I'm really grateful that we have this information out there for whoever needs it. So I just want to know that you've told us all the skills that chemical engineers need. So you've talked about coding and data analytics, and you've talked about 2 softwares. Please remind me what they are.
Super Pro, Designer, and Aspen Plus.
Yeah, and of course the basic tools like Microsoft Word and the rest. So are there any other skills that you think is essential for chemical engineers?
I think it's all engineers problem solving. Problem solving.
Yeah, problem solving. Exactly. Yeah. And you talked about something. You talked of costing. You said something about costing earlier. Was it costing?
Yes.
Yeah.
So these equipments that, we still have the flow sheet there, but like something like a storage tank, the last block that says drug substance storage, something like that. They're actually, what they teach you is how to cost a vessel like that or a piece of equipment like that. It's part of, I'm forgetting which textbook. been a while, but it is something that also comes into your overall analysis, because you don't want to just look into, okay, I've made my product, but then, okay, how expensive was it? How expensive were the materials that you put in? How expensive is the material to actually build all of this? Is it stainless steel? Is it carbon steel? Is it, what is all of that? So then to make your analysis complete, you then look into all of those factors, which also then helps, because I think these are also skills that, as I was saying, you can also use in banking and in consulting. So yeah, I think chemical engineering is just great. Yeah.
Perfect. Ah,
Yeah.
thank you. Thank you for that. So, we've seen the skills. Thank you for that recap. The
Mm.
skills needed to try as a chemical engineer. So, how did you go about? Is it something? Is it something that you have in your plan? Because something else that I usually encourage, and a skill that you have to have as an engineer, you have to develop a habit of active learning. So, like here, you're saying when you're studying, there was no data analytics, there was no coding. So, did you have to
Mm.
work on it later as you're working, or is it you have planned out?
I'm actually going to start learning how to code in Python language, because um, besides R&D, consulting is something that I would want to work into. I've conducted one project that was consulting-esque, but I realized that I need to know how to code to be able to make it more efficient, to work more efficiently. I think coding is a very good it's not like, I still have the degree. It's not like it's completely, if you don't know how to code, that it's not a train smash, sorry. But I think it's a useful skill to learn, especially, can't say this enough, with the way the world is going. Yeah, coding. So I am going to learn. Thank you
Okay.
for
All right.
calling me out on that, because yeah, it's one of my resolutions for the
Was
year. No, like, thank you. I have to be serious about it.
yeah, yeah. And
Yeah.
you know, you've talked of Python, and I've heard like also in my field, civil engineering,
Mm,
it's really applicable. So it looks like Python programming is almost like useful everywhere.
mm.
Yeah, I was once advised to consider upskilling on that area. I haven't done it yet, but I'm yet to look
We need
at
to
the
do
ways
it.
that I
We
can
need
be
to
able
do
to be
it.
helpful. Yeah, yeah. Okay, perfect.
Mm.
Yeah. So the next thing that I would like you to share with us, Ruparo, is
Yes.
ways in which you can collaborate with other engineers and even other professionals who are not engineers, and how is it that they come in? I mean, what inputs do they have to your work, and what inputs do you have to what they're doing?
Um, okay, I can only speak on my experience. Um, there was another project that was more multidisciplinary than just working with scientists. And in that's the role where I acted more as a consultant than as a researcher.
Mhm.
And it was new, because I don't know, I think engineers have a I think we think in the same way. I don't know, but the way that engineers think and the way that non-engineers, no, I'm not offending anyone, but like non-STEM people, actually, let me say STEM, I think it's very different.
Mhm.
And I've had to learn. Another thing is, yeah, teamwork. Oh, yes, I did mention teamwork is something that's very necessary in engineering.
Yeah.
It comes out everywhere. But
Yes.
like, I worked with a team that was actually business minded, so they were looking into commercializing. So some of the research that we
Mhm.
do at UCC in general, if it has good enough potential, it can actually be commercialized, and they are existing funders who can fund you to actually make it
Mm.
into a startup company. So it doesn't research doesn't just end in
Yeah.
the labs in the research group, it can actually, if it has enough potential, it can be commercialized.
Yeah.
So I was working with that department along with microbiologists. So they're literally microbiologists. I'm a chemical engineer, and I was working with project managers there and business minded people there. And so basically the project that we were working on, sorry, I work on a lot of projects, but it's this. So they're trying to, and I'm pretty sure you know how cannabis is taking over certain industries in Africa, or actually globally as well, especially in
Yeah.
therapeutics. Yeah. So what they were trying to do is they developed a method where, so basically when it comes to cannabis with the plant, right? There's a male version of the plant and a female version of the plant, but it's only the
What?
male, or is it the female? The female version. Yeah. Plants have genders.
Yeah.
Plants have genders.
Oh, yeah, and I remember.
So
Yeah.
there's a female plant and the male plant. I'm forgetting which one. I think it's the female one that no, it's the male one. It's either or that produces the CBD that's actually needed in pharmaceutical therapeutics that are cannabinoid derived. So they produced a method where instead of planting, because you could only tell which one is male and which one is female at harvest, but then you would have wasted time, obviously, because imagine you've planted acres of land, but only like not less than half of it actually has the compound that you want. So they developed a method where you could actually tell the gender of the plant from maybe after a week, I think, a week or a couple of days, whilst it's still a seed. You could actually, so that's what they wanted to commercialize, because obviously that's going to help save resources that would have otherwise been used to cultivate and harvest not nonsense, but like not useful plants. So they didn't know how to cost that. They didn't know how to cost to look into the economics of that. And it seems like the other department, they weren't keen on doing the nitty-gritties, the basics. And that's when I was called in as a consultant to use the data that they had developed and to make sense out of it in terms of money, basically, to then present it back to the board of funders and project managers to see, okay, is this actually feasible if we move on? Yeah. So in that case, the skills that I used were basically the data analytics and maths. Basically, that foundation in maths, it comes through in so many areas of this, of my basically. So in that case, so I had to work closely with people that think different, which is, it was interesting. It was interesting, a bit challenging, because obviously when you're working with a group of at least 6 to 10 people, and these are people who are experts in their fields and they believe what they say goes, or what. It was a bit challenging. I won't lie to you. It was challenging. But then I think I developed more of like the softer skills, the communication, all of that. Yeah. Especially like when it came to, I think the one challenge that we were facing as a collective was like transparency and communication, where I would receive information from one part of the team and then the other part wouldn't know. And then when we'd come together for like a progress update, people would be confused. Like, where's this coming from?
Lord.
So, yeah. So there, it wasn't much of my technical skills, but more of the soft skills, where I had to learn how to actually talk to people. Because if you can't talk to people, then even if you're brilliant at researching, if you can't communicate your research findings, or if you can't talk to people, then it's not, you need to, So that's the only instance where I've actually worked with people from different fields, like vastly different, because, otherwise, I really would want to work on all these things that I'm talking about in designing equipment. I want to do it because I learned how to do it, but I haven't actually physically on a plant where I can actually say, oh, this pump, I designed this pump, or this heat
Uh-huh.
exchanger, this reactor. I really would want to do that. But yeah, not yet. Not yet.
Is it
Yeah.
if you'd have an opportunity to do that, is it still under biotech or it will be something completely different?
I think that will be more of a design engineer, like a process design
Uh,
engineer. Yeah. Yeah. It
okay.
wouldn't be, I don't think it would fall under biotech. Yeah. It would be a
Okay.
different, yeah, type of role. Mm, yeah.
All right. And by the way, just to reinforce what you said concerning communication, I think
Yeah.
it's like everybody learns communication the hard way. It's like you're thrown into the deep end and you go there and you're so good with the technical things, and then you just realize nobody needs it. No one needs your technical, you know, skills.
Yeah.
You need to talk to people and you need to, and when you're talking about the working with different people who may not be thinking the way you think, and I'm thinking how that is just common across engineering, you know.
Yeah.
uh, yeah, so it's really beyond the technical things, like it's way much. So thank you for
No,
bringing that also to do on that as well. And now I want us to move on to uh, career paths, because you've talked about design. Did you say process design engineer? You said that if you'd go to the designing a plant and things like that, that would fall under, that would be a work of a process design engineer who would still be a chemical engineer. So, Rufaro, please tell us some of the career paths that chemical engineers have. Because if I'm being honest, when I heard chemical engineer, I was just seeing somebody
yes.
in a lab, in a laboratory with test tubes and chemicals and tests, you know. I thought of chemistry. So just tell us some of the career paths that somebody has. No, it's true. Because it's true. I'm not lying. And you know, if you look at
Oh,
this other side of if civil engineering, I have to tell you, when you thought of
yeah.
civil engineering, originally you thought of buildings and roads, and that's where it stopped. And there is so
Yes.
much into it. So we don't want to just think of chemical engineering and think of a laboratory and chemicals and a test tubes. So please let us know some of the career paths um, that one would
Okay.
have should they want to venture into this field.
Okay. Where do I even start? Um, we can start off with the obvious, the process engineer. So they basically it's basically everything that I've discussed before with being a process engineer with regards to equipment and all of that. But you can also go into quality control, those skills that first year of chemistry, I don't know how it is on other universities, you can also use those skills into quality control. So basically after the product has been produced, you now have to test and make sure that
Mhm.
it complies with whatever the health or whatever guidelines there are that exist. You can be a safety engineer and basically just monitoring processes and making sure that temperature is
Okay.
controlled or pressure is controlled or
Mhm.
all of that. You can be an environmental engineer, sustainability and environmental. So basically assessing how whatever process it is that you are involved in, are the emissions according to the guidelines? Are we polluting water? Are we polluting the air? You need to make sure that the company isn't doing that, and that's a role that a chemical engineer can take on. You can go into
Mhm.
so these beginning ones, they can go into any type of industry, because as long as a product is being produced, there are some guidelines that need to be adhered to, and a chemical engineer can come in
Okay.
through that. So that whether
Mhm.
it's like maybe it's a paint company, you're making paint, or it's food and beverages, or it's
Uh-huh.
pharmaceuticals, or it's
Okay.
energy. So
Mm.
oil and gas, petrochemicals. So you can also use those career paths do exist in various industries. Another role is the consulting that I was telling you about. You can go into consulting.
Yeah.
Academia, I don't know why people don't like talking about academia. Academia is actually a
Yeah.
really good path to take.
Exactly.
Um, Academia, research and development. Yeah. So there are different roles. It's just that sometimes you don't know whether you as a chem, because you'll come and you say, "Oh, I'm a chemical engineer," but then the job description or the title doesn't say chemical engineer. So then you think, "Oh, I
Mm-hmm.
don't actually qualify." But then when you read the description, this is for people who are job hunting. If you read the description, you actually
Mm.
see that, oh, actually, as a safety, I can be a safety engineer because I know about health,
Mm-hmm.
safety, and the environment. I know this and this and this. I can
Yes.
do that. I can prepare this. Or you'll find that the skills that you've had from chemical engineering can apply to different roles, quite a lot of roles. Yeah.
Mm.
Yes. But I can also
Okay.
touch into, I don't know if you'd want me to do this now, but like just the different branches, like the different actual fields where you can, where you'll be
Mm-hmm.
appreciated as a chemical engineer. I just briefly touched on
Yes.
them, but then
Yes.
I don't know if you'd like me to go into more detail, like different companies as
Yes.
well, or
Exactly.
oh, okay, sure.
Yes.
Okay. So what I was talking about, the oil and gas, so petrochemical, so making your fuels, chemical engineers are needed there. So I know, I'm only saying I know of these things because unfortunately some of these bursaries are only applicable to citizens. So for me, unfortunately. But like Sasol and BP, Shell, Chevron, those are all companies that work with fuel. And you may
Mm-hmm.
think you wouldn't actually realize that you don't just all of a sudden get fuel. You need to first extract it from the ground, from natural oil or crude oil,
Yeah.
and then you need to separate it out into your what is fuel? What's fuel? Diesel, sorry, diesel, petrol. These are all different types of chemical compounds that need to be, sorry, I'm zoned out. What is fuel? That need to be separated out into whatever it is that the desired products are. So it doesn't just start as you just get fuel. It needs to be purified. It needs to, and all of that a chemical engineer can do. So yeah, Sasol, Shell,
Mm-hmm.
even Total Energies, as long as it's um fuel industry, fuel company, then a chemical engineer can definitely be there. Um,
Yeah. Okay.
Another, I don't know if you want me to go into more detail, but like, because I'm just gonna move through a couple. The main ones that I know
Yeah.
are the
Yeah.
ones that
So we can.
I'm.
Yes, please.
Yeah,
Yeah. Of course. Yeah.
yeah. Pharmaceuticals and biotech, which is where I am. I think I've described the R&D side, the research and development aspect of it, but then you can also be, because remember, chemical engineering from raw material to a final product. So with pharmaceuticals, the flow sheet that we showed recently, just a few seconds ago,
Yeah.
basically a chemical engineer can be there, whether it's actual optimization of the process flow sheet, yes, something like that. That's pharmaceuticals, that's in biotech. Whether it's that, whether it's also what I was saying, quality control, making sure that the vaccine that you've produced is actually safe, is actually safe. There you'd work with people more in the medicine in the medicine field. So those that do clinical trials and all of that, that's where you'd work hand in hand with them, just to make sure the safety of whatever product you have. So that's vaccines, that's any pharmaceutical therapeutics, so even Panado, paracetamol, anything a chemical engineer can be part of,
Mm-hmm.
whatever that team looks like, whatever the working team looks like, the workforce, the chemical engineer can be there. Some of the pharmaceutical companies are the one that I worked worked with Afrigen. There's also this one called Biovac. They mainly do vaccines. And then there's also Guess Labs, which is
Okay.
it's a company that works with, it's more of a niche because they're working in with this cannabis infused therapeutics. So that's also another company that's it's still quite niche in Africa anyway. And then in the globally, you
Mm-hmm.
have your Pfizer, you have Thermo Fisher Scientific, you have,
Yeah.
so there are different companies where I think if another thing, sorry to digress, but like having the skills is one thing, but another thing is knowing how to network. And yeah, that's
Mm-hmm.
a difficult one, knowing how to network.
That's a good one.
Because yeah, networking is something that they don't teach. They don't teach you how to network
Ah,
because
got it.
you may be skilled.
Yeah.
You may have all the skill, undergrad, whatever the degrees are glowing, you have them. But it only just takes one person to give you a shot. But nowadays, yeah, you need to
Uh-huh.
network. And yeah, so that's something that I'm bringing that because I'm actually currently struggling with that. I was telling you earlier how I get ghosted on LinkedIn from like maybe
Yes.
recruiters or hiring people. Yo, it's difficult. It's difficult. It's difficult because
Yeah.
I would want
But
to. Yeah. Sorry.
what I
What were you
wanted to
saying?
say
Sorry.
was it's very it what I wanted to say is yes, it's very difficult networking. It comes naturally to some people, the people who communication come naturally to, but then there's some of us who we have to be very intentional and learn the skill, how to communicate, how to network. Yeah.
Sorry to digress a bit. Do you have any tips for how to network? Just a very quick tidbit. No,
No, that's a good
serious,
idea because
serious.
I'm gonna write it down, Rufaro, and we're gonna do this. We're gonna do content on this one because
Oh
I
my
don't think it's just
gosh.
us. I have to be honest. I don't think it's
Yeah.
just us. But then
Okay.
personally, what I've done before we get to like the deep stuff and what
Yeah.
experts recommend, what I've done is to um there are events that I go to. Like sometimes there are this you do have the association, the engineering associations in South Africa, right? So if you
Mm.
join those ones, and then sometimes they would have these events, and you go to those kinds of events. I've had, I mean, two different kind of scenarios. There sometimes I go, and I feel so intimidated, and then sometimes I go, and I'm just okay, and I realize the difference is if you just open up to somebody and just start having a conversation, it's gonna be very difficult at the start, but then it's going to ease in, and then it's going to be very easy. But then if you don't and you just give in to that intimidation, then it's just gonna you're just gonna have a bad, if you're having an evening, it's just gonna be a terrible evening. So when I was I have to say, I was mentioning that some of these things you have to actually be intentional. And for me, what I did, especially with public speaking, is I went for training. So when I was being trained on public speaking,
Mm.
now what I was told is that you see the way sometimes you look at somebody, you're like, this person, I don't think like they're even afraid of anybody. I mean, they can just go and talk to a million people and they are not even shaking. So what I was being told is, you see now the butterflies, they never really go away, even for the people who look like
Mm.
they're great speakers. So they if with practice you learn to ignore the butterflies and the fear and the intimidation. So when you ignore it and do it, the more you do it, the more you get the confidence to do it, and you get better at it. So then it's like you're silencing the butterflies, but they will ever be there, even for great communicators. And for me, that changed it for me. And she was telling us
Wow.
that um, yeah, she was telling us if you want to swim, and you don't get into the water, you'll never learn how to swim. So just do it no matter how, even if you're doing it, you're talking to somebody and literally you feel your voice is shaking. You just go ahead and do it.
Yes.
Oh my God.
Yes.
Yeah. But
Yeah,
for some people it's
thank you.
natural. For some people you're gonna have to be very intentional about it and practice. So
Okay.
me, that's what I do. Yeah.
Thank you. Thank you so much for sharing that. Yeah. Yeah,
Yeah.
very encouraging. Thank you. No, really, thank you for sharing that. That's very encouraging. Yeah.
Oh, you're welcome. So, actually, I've
Yes.
forgotten what you were talking about. You're talking about where we're working,
Oh, yes, yes, yes.
and
So I
then we moved
mentioned.
to working. I'm supposed to be the host, and I'm supposed to get a hold of everything. But that's a very great discussion, Rufaro. And I actually wrote it down. And I have two things that we're gonna do as a follow up to this conversation:
Mm,
research, soft skills. So that would be networking and communication.
mm-hmm,
And I really look forward
mm-hmm.
to do it in the coming weeks or months. And let's see what
Definitely,
we'll
yes.
discover. Yeah.
Yeah,
So
honestly,
I'm
no.
wondering if you
Yeah.
finished. Yeah.
Sorry,
Sorry,
come
sorry
again.
about that. I was wondering if you had finished your thought on where to work and the career paths.
Oh,
Had we gone through all of them?
just one more. One more. Food and beverages.
All right.
Food and beverages. You can
Mm-hmm.
also work there. So certain companies that I know of that also have bursaries and stuff is Unilever, Coca-Cola, Pepsi, Nestle, all of those
Mm-hmm.
companies, sorry, they also hire chemical engineers, process engineers, to
Mm-hmm.
also help
Mm-hmm.
with quality control and also just safety and all of that. So it's not just restricted to anything small. Actually, you can work in different companies. These are just the few that I've mentioned, as well as consulting. I had mentioned earlier, but like consulting is also a career that you can pursue with. There's McKinsey, there's BCG. There's so as long as a consulting firm, I'm just naming the big ones, but then any kind of consulting firm.
Yeah.
And you can also work in water treatment plants as well. There's just really a
Mm-hmm.
lot of places where you can find chemical engineers being
Yeah.
appreciated.
Okay.
Yeah. So yeah, besides that, and the banks as well. You can also work in maybe data analytics in banks. That was basically an overview of some of maybe the main fields where chemical engineers end up working. And to actually, what surprised me a lot is how most of the people that I've learned with, only a few of them are actually doing something that's
Yeah.
chemical engineering related. Most of them are in consulting and banking, which is actually quite interesting. Like, I
Okay.
don't know why, but that's just something that I've
Yeah.
noticed, which is also why I'm maybe. I also want to pursue that and see what it's like being more corporate, being in the corporate spaces and
Mm-hmm.
consulting, which is why I'm trying to Python. We must learn Python, how to code, as well
Okay.
as other
Okay.
skills, other like
Deal.
upskilling, other certifications that are needed in doing
Mm-hmm.
that. Yeah. But yeah, I think that's actually most of everything. And academia teaching, sorry, how can I not say this? I have actually lectured
Yeah.
part-time as well.
You have.
Um, Actually, towards the end of last year, I was lecturing second years, helping
Okay.
them prepare for, yeah, helping them prepare for. So, fortunately for our department, if you don't do so well in the exam, you have a chance to write a supplementary exam. So basically, it was like a crash course over a couple of weeks, I think, where we're just going
Mm-hmm.
over all the material, learning material, and then you write the final exam again. So basically, I was a part of that as well. So teaching is also something, because once you have obtained the degree, you can also transfer that knowledge to other people, students who were like, you've been in their place, you've been there, you understand
Yeah.
how maybe some of the concepts were difficult to understand from lectures, because when you see a lecture you're like, oh, okay, this is an expert in their field, but then me, I'm just, I'm just here, I'm just like, I can just and because I've been there, I understand sometimes that whole being able to be relatable to other students, especially being a Black woman in South
Yeah.
Africa. Also something that maybe sometimes it's hard to ask the lecturer, oh, but I didn't get this. But then I've noticed that a lot of students are actually more willing to ask us, like postgrad students, because we also help with tutoring as well. So besides part-time lecturing, we can also help tutoring and help undergrad students maybe with concepts that they don't understand, or if it's a tutorial, if there's questions where they're like, this doesn't make sense, they come to us. And that's
Okay.
also a way that I also find I really like helping people. So if that takes you any step closer to your degree, then I'm really there to help. And yeah, that's another area that can be explored, just depending on you as a person if you'd want that. But
Yeah.
academia teaching is something that I really do also. Yeah, I also really like.
Okay.
Yeah, that's, I think I've covered
Did
most
you
things.
mention did you mention research? Oh, you mentioned research because that's where you work.
I did, yes, research and development, yes.
Yeah,
It's
yeah.
just that I'm more in the bio space, but you can do R&D for almost any company, just depending on if they have that in their work portfolio. Or yeah, but R&D is definitely. But I also think it's easier for me because I've been in research, like after having done my master's. So there's
Yeah.
also that. Yeah.
Is that
Yeah.
why you did your master's? Is it because you wanted to go into research?
I was lost. I didn't know what I wanted. I didn't know what I wanted. I really, you know what I think you said this earlier on, but I got to final year of my undergrad and I had absolutely no idea where I was going next.
Oh Lord.
Nothing. Nothing. There was absolutely nothing. I just wanted to get the degree because towards the end, yeah, it was getting a bit difficult. But fortunately, so what they do, or basically the degree that I did, it's an honors degree. So in your last year, you have the final design as well as a mini thesis that we had to do. So that was more of partnered work where you're in a pair, and so there are a couple, I think maybe 7 research groups in our department. So basically different supervisors or academics, they have parts of maybe their research that they give to undergrads to perform, like if it's experimental work or if it's computational work, they give you, so it's basically a part of their research that they want you to do, and you have to basically do whatever I did experimental work, whatever the work is, get your results, and then create a report, like a proper intro, methodology, all of that, and write a report and then present on that. But based on like actual research that's being done within the department. So in doing that, I was placed in the bioprocessing research group. And it was only then, like the exposure to, besides the actual work, which I find fascinating, but the work environment, I really enjoyed the people that were there and the nature of the work as well, because it's kind of interesting working with living organisms as opposed to just like maybe, I don't know, but yeah, I really just like working with living organisms. And so that's your bacteria or your enzymes that I was talking about. So after having been exposed to that for 6 weeks is when I was like, you know what? I started asking around. I started just talking to people and finding out, oh,
Yeah.
okay, you're drinking master's? How do you like it? How's this? How's that? And then from doing that was when I then approached the director, who actually ended up being my supervisor.
Yeah.
And I just asked him, okay, what projects do you have for next year? This. And from there is when I actually started. I was like, okay, masters, let's do a master's degree. Because I became, you actually are right. I became interested in the work that they were doing, the research work that they were doing. And then
Okay.
so from there, it's just been research. Yeah. Yeah.
Okay. All right. So
Yeah.
okay, that's good to know. The reason why I asked you that is that's something that
Mm,
I've been asking because I was looking forward to doing also shedding light on that area because mostly after school people don't know the right reasons to do a master's. Um, I mean, you can go into it and then you be disappointed because the reason why you did it is not it did not work out at the end.
mm,
So I just wanted to also give information on that and shed a light on that area. And I'm going to
mm.
involve you in that when I do it. Oh my God, we need to do lots of things. That's the third thing we need to do after this conversation. Yeah, the third. Yeah. So what I wanted to ask you was concerning consulting.
Mm,
You say that there is the option of working for consulting. So, when you say consulting, for me as a civil engineer, in my head, I'm thinking because for civil engineering, consulting firm is, I can start a consulting firm as an individual, as Marion. I can, when I meet all the qualifications by the regulator, I can go open up consulting firms. And then when there are bids, I go bid if they want to build a building somewhere or a road,
mm.
then I can bid and get the work and do it. Is it the same way for chemical engineers? And then what I wanted to ask is, what kind of projects do you do in these consulting firms? Because I'm thinking of if it's for me it's easy. The government will go say we want to build a road from here to here, and then as we go and say we are interested, we have the qualifications and the people and the capabilities. So, what kind of projects do you do in chemical engineering?
As a consultant, very
Mm-hmm,
thank you for your question.
mm-hmm,
I can speak to um, a friend of mine. Yes, actually, she works for a minerals related kind of consulting firm. So what they do in that space. So I didn't talk about mining. I'm sorry, I didn't mention mining. You can go into
there is.
mining as well. Mining and
Okay.
metallurgy is another field, sorry, that you can also go
So,
into as
how
a
how would
chemical
mining come
engineer.
about?
Sorry, come again?
How what you'd be doing in mining? I know
Oh, in
I'm
mining. Okay,
picturing mining,
so
and I'm seeing big
that's
machines and,
right.
and and they're digging things underground. So, where's the chemical engineer coming in?
So what? Okay, so a chemical engineer, what we can do actually, it's called the branch of it is called metallurgy. So basically,
Mhm,
when you get after the rock or whatever it is has been mined, because remember, it doesn't come out just as gold, like I have gold here. No, it comes out in embedded in like rocks or other different materials, right? And you at the end of the
mhm,
day want your final product, which is maybe your gold or your diamond or whatever it is that
mhm.
you're mining. So what we do
Okay.
as chemical engineers, because yes, there's a research group actually that specializes in minerals and
Mhm,
metallurgy. What they do is that they take that ore and then by a method, I think there are different types of methods, but the one that I know of is called flotation. So basically
okay.
it's a chemical kind of environment where why are you looking like that? It's a chemical sort of environment where
Mhm.
where
Sorry.
you flotation. I please chemical engineers that are listening to this. I don't I this is just based off the top of my head what my friend would tell me, but like basically you'd float, what is floating? You'd submerge it into a certain kind of chemical such that those other unwanted, like the debris, the other particles, they get separated out. And then from there, you get your final grade of ore or mineral or whatever it is that you want. And then from there, there's a department for metallurgy, which actually, because it might not just be gold, it might be gold with a little bit of something in it, or it might be copper with iron. So there's another section that actually looks at what the chemical properties of the grade of that ore, what it is. So it basically tells you, okay, how much of this is actually copper, how much of this is actually platinum, how much is, yeah. So which is also a little bit of analytical chemistry. I can see a little bit of chemistry coming into just analyzing that material, but then the chemical engineer would have separated out that whatever ore or whatever it is from the big rock or the sand or whatever it is. Yeah. So what my friend does, she works for a consulting company where different mines, they have contracts with different mines where they send in like a sample from their mine, a sample from wherever it is from, yeah, they send in a sample and then they want it analyzed for them. They want to know, okay, what is the grade? So basically what I've described is what a consulting firm for metallurgy would do for in the mining space. So basically they say, okay, this is what we have. We want to know this and this. Can we use these? So what happens is for different minerals or materials, you need different chemicals in order for you to actually get your final product, the final purified product. You can't just use different things and expect for the best, because the different sand types, there's a lot of things that you need to take into consideration, which the chemical engineer or metallurgist or mineralogist knows. They know that. So they might come and say, okay, we've been using this X, Y, and Z for us to purify this. We want to see if maybe if we use a cheaper chemical compound, what would that mean? Like, is it possible? Does it affect the grade? Something like that. And then you then have to do a sort of analysis on that and see, okay, they've done this. What if we change this? What happens? And then you write down your report findings and then send it back. Yeah. So that's a
and
sort of
isn't that the
example
essence of the problem solving that they are? Problem solving right there.
Yes. Yes. Yes.
It's what engineering is all about. Okay.
Literally, yeah.
Yeah. So that was an addition to the career options that we have in chemical engineering, mining. So back to projects. Remember the question I asked on projects, kind of projects that you do? But that even I feel that even the comment you made on mining partly answered that question. Now, what I'm thinking is now how do these projects look like? Is it that there is a mining company and do you see like environmentalists in our work? No. That wouldn't be a good example. What I meant to ask is, do you have like a project, like certain kinds of project, like for civil engineering, you have road projects that it's not only civil engineers that will work on it, but they will be like the lead people working on them. So like what kind of projects?
Sorry, wait, I didn't hear the end after having a lead. Sorry.
I'm saying, what kind of projects would this be? What kind of projects?
So are we talking about like with regards to the example that I gave, or
no, generally for chemical engineering? Yeah, what type of projects do you do? I think you
where
mentioned
we are
some
the
of them. I
lead?
think yeah, I'm thinking vaccine development, things like that. I think you mentioned some of them, but then can you think of others? Maybe that we haven't gone.
At the top of my head,
Yeah.
I am blanking out. Sorry.
No.
I'm I'm trying to think of something that could be done maybe in the food and beverage industry where uh I always like having examples that are based off real life experiences. Um,
Yeah, yeah.
but I think I've already like talked about most of the things that
All of them.
I am aware of. Uh,
Okay. Can I ask something while you think about it? Because I'm just
okay, sure,
thinking
yeah.
right now. Is it that chemical engineering is more uh, operations than projects? You see, there is project and operations. So, or is it both?
Mm,
So, I give an
mm,
example.
mhm.
If we are, if we are designing a nuclear power plant, that's a project. But then if we are running it and you were talking about the equipment and the water and the temperatures,
Oh,
so I'm guessing that
yeah.
will come in. So is it, or do you do both? Do you do both the project and the operational part of it?
That's a very good question. That's a very good question. And to answer you, I think it's case dependent, but it can be both. It can be both because you could be a process engineer working on a plant, fine. Maybe you're producing whatever you're producing. But then, yes, you are ensuring that the process flows smoothly, you're checking everything, but then it may come up similar to how I was talking about the consulting job where the company decides, hey, actually, I feel like we're using too much utilities, or maybe we're using too much of a heating medium or cooling we're using too much water to cool the system.
Yeah,
Isn't there
yeah.
perchance a way where we can reduce our energy consumption? What kind of way can we integrate the heat that is already in our process instead of
Mhm,
um what you call it, procuring more cooling water or whatever cooling
mhm,
medium you have? In that case, it
mhm,
would be a project, but then you are still someone who is actively working on the plant, but you could be called in to handle that as a project. Yeah, I
mm.
think it's case dependent. It's case dependent.
Okay.
So it's either they would ask you to do it or they'd then
Mm.
outsource. They would then
Okay.
outsource. Yeah. But it just,
Okay.
yeah, thank you. That's a very good question. That's a very, very good question. And I hadn't thought
No.
about it like that. Operations or projects, both,
Yeah,
both,
yeah. Both of
both.
them. So they would work in both.
Mm,
All
mm,
right. All right.
definitely, yeah. That's a very good,
Okay. So
very insightful. Yeah.
all right. All right. So one thing I want you to, I don't know how you'll put it, but for the sake of one viewer who is asking about mechanical engineering, so is asking about your take on mechanical engineering, but because you're not a mechanical engineer, maybe you could tell us the kind of collaborations that maybe you have and the kind of contributions that mechanical engineers
Mm,
might work or the ones that you have into their work. So maybe that shed light on that area.
mm. I can think of one particular colleague of mine. He, yes. He, okay, I'm seeing. Hi, Jackson. So I have a colleague of mine. His undergrad was in mechanical engineering, if I'm not mistaken, but he did his master's in chemical engineering. So what they needed was a cross between. So what I was talking about, how we can design a piece of equipment, right? But then it's the mechanical engineer who needs to make sure that it actually works. So he worked with
Mm-hmm.
chemical engineers. And so it was in this research group which deals with ice. So think of the Antarctic. Think of how, so I'm not too sure of the chemistry or the geo, or I don't want to lie, but basically, as ice melts or as it forms, rather, there's a different, there's a, how do I say it? It has certain properties that it has, and you can use the properties from that over years to predict the future not the future, but the future of ice sheets, because you know how they're melting and then what global warming and blah blah blah. So what he did was that he worked with a chemical engineer in order to create a certain device. I'm just not sure what the device actually was and what it did, but that equipment they needed to use it to analyze ice samples. So literally they traveled to the Arctic or the Antarctic, extracted ice, and then he had to use the equipment that he had designed. So he designed it with a chemical engineer such that they could use it for analysis. I'm saying things very high level because I'm not really sure of the correct terminology. I'm not sure. But that is an example of a collaboration that was done across mechanical and chemical engineering departments, which I found really, I was like, oh, wow, I thought you're mechanical. Why are you in chemical engineering? But yes.
Yeah. Okay.
Yeah. So that just goes to show a practical example of how chemical engineers can work hand in hand, or definitely we work hand in hand with mechanical engineers, because by myself or as a chemical engineer, I wouldn't have been able to actually create whatever it is that it actually works. I've seen videos of, he finished recently. I've seen videos of the equipment that he created, designed, tested.
Yeah.
It works. Yeah. But I'm so sorry. I'm speaking high level. I'm not really sure of the intricacies of mechanical. I'm so sorry, Jackson. But we do work all together, as I think we mentioned earlier on with Marion, that engineering, we're all interlinked somehow, some way, always. Yeah.
Yeah. Sure.
Yeah.
Well, thank you for that response.
Sure.
I'm thinking to myself now, because we've gone through your journey, we've gone through, and Rufaro, speaking of your journey, you mentioned challenges that you faced, which you're looking forward to hearing. But you've also gone through the career paths, we've gone through the skills we need, we've gone through where we're working, where we can work, and what kind of work can we do as chemical engineers. Okay, not me, but
yeah.
But then I'm thinking now, could you please tell us the highlight of your career? And I don't know if we should start with the highlights or the challenges. No, let's start with the challenges and finish with the highlights.
Challenges. Challenges.
Yeah.
Challenges. It was hard because, okay, immediately when you start your undergrad, they place you in these groups that I was talking about, with all the project work, because teamwork is a very big aspect to engineering, as we just talked about. So it was hard because you are sitting in a group of diverse people, because UCT is quite diverse. So people from different backgrounds and with different work ethics, it was difficult because sometimes you're in a great group, everyone works on time. The other time, maybe life doesn't always go according to plan. Maybe something family happens and that person is not available, but then now you can't do your work because they haven't done their work. And then it's just, or someone just stops contributing to the group and they just go quiet. And now the workload is on you. So teamwork was something that I struggled with. I won't even lie, I struggled because I was very used to working by myself. Okay. Even like in high school, I would study by myself. I was just, but then it really helped me also come out of my shell a bit. I am shy. I get nervous when it comes to speaking and all of that. So also presentations were something that
can I just interject? Can I just say something?
Yes.
No one can tell. I'm telling you, like, no one can tell. You look so extroverted. I mean, I didn't expect you. Yeah.
No, I am shy. I'm telling you. So it was difficult. Like I still remember my first presentation because I thought that, yes, it's good to have like cue cards or to write down a speech. But then the problem with doing that was if I didn't get it word for word, I would stop and I would just be like, oh, and I'll just withdraw. And so that was a challenge that chemical engineering helped me because of the presentations that we do I'm telling you, every semester, you know, you're having a presentation either by yourself or as a group. That
Mm-hmm.
was difficult because but it really did help me because now if I have to present something, yes, I'll have cue cards or something, but then I'm able to get my message across. And yeah,
Mm-hmm.
so it was challenging, but it helped me. It really helped me in the long run. Another thing
Yeah.
that was challenging, just the jump from high school to uni.
Mm-hmm.
I struggled. I struggled with the workload. I struggled particularly with maths. Maths, I still remember my first class test came back with what was it? I think I had like a 20 something percent. And I was like, what? Because obviously you're not just a UCT, because normally UCT people were basically top in their classes back in high school. So now being put in a class with the smart people, the smart kids,
Mm-hmm.
it really did something to my confidence when I wasn't doing as well. But then what I learned, that's also when I learned another aspect of teamwork. You can't study by yourself. Because I used to be like, no, I'll just do like the whole
Yeah.
thing of being individualistic. No, it doesn't work.
Yeah.
You need to work with
Mm-hmm.
people. You need to
Yeah.
work with people. You need to create, be part of the community, whether it's not just, having a good time. At the end of the day, you need a degree. And you need to work with people who also want the same thing, who are also focused. So from first year, after I got that 28, that was the lowest mark I ever had in my university career. I was like, nope, this is not who I'm going to be. This is not
Yeah.
who I'm going to be. So from there, I don't want to lie to you. After first year, the rest of my undergrad journey was smooth. Once I
Mm-hmm.
realized, no, this is the work ethic that I need. I need to always be working hard. I need to always be, I was like, okay. But not to say that I was always just working, just in case other students or aspiring engineers not, you also need to like have a balance. You should also have a social life. Even if it doesn't mean
Mm-hmm.
being outside and always partying. Oh, but you need to also have some time to refresh, relax, breathe,
Yeah.
do things that you enjoy, join a society, start a hobby, all of that. It really helps. It doesn't just, it really like molds you into becoming a more wholesome person because you can't just always be work, 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 work. So I think,
Exactly.
and I didn't learn that by myself, by the way. I had a mentor. I had a mentor
Wow.
from my first year up until final year. And he, no, I'm telling he was amazing. Because after I failed that first test, I was like, no, I'm going home. I don't want to lie to you, I was so demotivated because I was never that child. 28%. I was never that child. I'm not lost with anything to say anything against other students who are going through that. No, that's not what I'm trying to do. But I'm just saying, after having experienced what I did in high school and then university humbled me. It humbled me.
Mm-hmm.
I wanted to leave. I was like, you know what? I'm going back to Zim. I can't do this. And he was like, and do what in Zim? What are you going to do? You're going to go back home and do what? No, you need to work.
Mm-hmm.
You need to do this. Come on. And like, he really helped me. And like, yeah, I honestly, he really like talked to me. Like, he properly gave me tough love, if that makes sense. And from then
Yeah.
on, I think my undergrad was a breeze. But now, post grad, post grad was a whole other beast. Post grad was, I don't want to lie to you, Marian. My master's was hectic. And it wasn't hectic because of the work, it was hectic because of the people. Not the people, one person, but I can't name him or tell you what relationship I had. Because what if he watches this? When you're working with experts
Yeah.
and you're just coming in, you're fresh grad, you're just, you don't know much. So what happened with my thesis when I started my project, my master's? First of all, I started in COVID.
Mm-hmm.
So, and my work, as I explained, was experimental based. So I needed access to the lab, but I couldn't because it was COVID. So I started by basically not doing anything. because
Okay.
my master's was research based. There wasn't any coursework. There wasn't. It
Mhm.
was research based. So in the
Yeah.
first year, I literally could not go to campus. So I couldn't do anything in the first year, which was, I mean, no one, like, obviously the whole world like was at a standstill, obviously. But yeah, so the first year was terrible. The second year, because my master's took me very long, and I won't say that
Mhm.
ashamedly or anything. It's just the reality. And it was beyond my control. Things just honestly were not going well. Things were going terribly wrong. In my second year of my master's, um, that enzyme, the one that I was telling you about from the mushroom, it
Mhm.
wasn't working. For a whole
Okay.
year, it didn't work. It didn't work. And we tried. And that thing of being an expert and saying, no, but it should work, I'm there. It's
Yeah.
not working. And that when you're consistently trying to say, this is not working, this is not working, no, it should work, it
Yeah.
really made me question myself. Like,
Mhm.
is it really me who's not doing this right? But then I somehow, because I was surrounded by experts, I felt like, or like just like PhD students or other master students who really didn't know what I was doing, so they couldn't really help. I felt like I
Mhm.
needed to figure it out by myself. So I went back to my secondary, whatever, in high school, where I was like, no, I need to do things by myself because it's my master's
Yeah.
degree. I didn't ask for help until the year ended, and I hadn't asked for help and I was stuck. This is supposed to be a 2-year degree. I've gone through
Mhm.
2 years and I have nothing. Eventually, in the third year, so 2022, was when finally, finally, after another expert sat, they were with me in the lab, they saw me do everything. And that's when
Mhm.
the other expert said, this is not working, was when
Yeah.
we decided to change direction and use another source.
Yeah.
So once we got that one from the university, because the one that we were trying to use was one that was developed from another university. So then we ended up using another one, and that's when it started working. And I did all my research work 2022. I wrote up my thesis in 2023, and then I had actually finished in that year, but then graduation was only the next year. So even though I'd actually technically finished in 2023, I
Yeah.
only graduated in 2024, which looks like a whole 5-year degree just to do a master's, which
Yeah.
I think I'm in a better space to be talking about it now as comfortably.
Yeah.
But what I went through it was terrible because besides the research of it not working, people also weren't working.
Okay.
So marking a thesis isn't supposed to take long, but I don't know what was happening with the admin. So that's also when I learned that if I want something, I need to actually be active in getting it. Because
Yes.
if I just kept quiet and said, "Oh, nothing is happening. Oh, I haven't heard anything,"
Mhm.
I had to fight, Marion. I had every
Yeah.
day. I'd been knocking on doors. Hi, what's
Yeah. Yeah.
happening? Where's
Mhm.
this? Because they wouldn't reply to emails. They wouldn't reply, and I'm just sitting there. Hi, hi. No, I had to. So that's why, yeah, I learned a lot in this. Like my postgrad was very, yeah, it was
Mm.
difficult, but like I learned a lot. I think my postgrad was more challenging than my undergrad. My undergrad, once I
Mm.
knew what to do, things flowed.
Mm.
But then in masters, I
Yeah.
didn't know what to do. It's a whole different ball game. But this is not to discourage anyone who's
Yeah.
listening or watching this. Not all experiences will be like what I experienced. And
Yeah.
in anything that you go through, there's always something to learn. It took me
Exactly.
a while, but then, yeah, you will always learn from something. Yeah. But it was really challenging because it really makes you like lose your confidence and in your
Mm.
abilities. But like, I passed and I got a distinction. So clearly, you know, like it was just other factors that were beyond my control that were
Yeah.
prolonging this process now that I think about it. But like, yeah. But yeah, if you want to pursue a master's, I think it's worthwhile, especially if you like, yes, to answer your question, you need to like the research. If you're just
Yeah,
doing a master's for fun, you're not going to enjoy the process. I really enjoyed the research that I did. I
yeah,
really enjoyed,
yeah.
like,
Mm-hmm.
I think, yeah, I enjoy research. So I'm really happy that I did end up pursuing my master's, because if I hadn't, I wouldn't have discovered that I actually love research. So yeah, yeah,
That's so profound, Rufaro. It's so, I have to tell you, I'm hearing that story and I'm telling myself you're God sent. Because when you talked of that, I thought of an experience I had myself, not in academics, but in the field where I found
mm,
myself in a deep end. I don't know who to ask questions. Nobody around me can help me. And it was so frustrating. So I'm
mm,
thinking, you're talking, I was thinking to myself, so first of all, like, when somebody hears about things like this, I have to say, for me, I know people, you get blue ticked on LinkedIn and things like that, but I know people that I've reached out to on LinkedIn and they have helped me. Like, I in that place, there's an engineer I reached out to on LinkedIn. We have never met, but he helped me. So you see, when you talk about
ah,
things like that, like literally somebody can reach out to Rufaro. I mean, I'm going through my MSc. I don't know what to do. I feel stuck. And as you're talking about it, how difficult it is, I always find the most difficult experiences to be the one that builds us the most. And looking back, I don't know if it's that way for you. It was in the at the end, if it was that way for you, but such
mm,
there's something that builds in you. So when you look back, you've learned so much, and I just something just happens when you get through such experiences. It builds character. You learn a lot, and
mm,
and I feel like in the end, it always turns out to be worth it. In my view,
definitely.
I'm not sure it worked out that way for you.
No, definitely. I agree with everything you're saying. Yeah,
Yeah.
it does.
Mm.
It does.
Mm.
Yeah.
I appreciate that part the most because I really think we need to. I just love people to share, share the problems, share the information, just share, share,
Yeah.
share, share.
Mm,
Because somebody's going to be in something and they're going to be thinking, oh my God, what's wrong with me in the world? Is it me that things are not working out for me and stuff like that?
yeah.
So sometimes, yeah. And when you mentioned about having a mentor, I think that also is when you feel you're getting stuck somewhere, just look for somebody who you can share with. I learned something, Rufaro, when you're talking about teamwork. I used to also have
Mm,
a problem with working with other people, but something that I learned over time is when I'm working on something and I involve somebody, sometimes they don't even help me. If you go ask somebody a question, just saying the question to them, I mean, it just gives you a different kind of you can even get the answer before they tell you what to do. I mean,
yes.
ask somebody something and you already know the answer. I mean, you go back, you know exactly what to do. But if you stay there working on it yourself, I mean, you can take hours and hours and hours. So I really appreciate you sharing that story. And oh my
Mm.
lord, I have to say it's the highlight of this discussion for me.
No, 100%. 100%. I agree. Yeah.
Yeah,
No,
yeah,
no, it's, yeah.
yeah.
Mm,
Oh, so that's so great. I mean, you ended up doing so well. And no wonder your research sounded so great and unique when you started. Me, I had the mushrooms and metals. I was like, what? What? How can you use a mushroom as a metal catalyst? Yeah. And sometimes things that are worthwhile take time.
yeah. No,
Yeah.
definitely. Definitely.
So thanks for
Yeah.
sharing. Um,
No.
and you also to share with us. I don't know if there are any other challenges that you faced apart from those ones.
Mm, um, I think to be honest, it just goes back to the soft skills, because I think technical skills are easy to learn or
Exactly.
easier to learn and to be
Mm-hmm.
taught. But
Exactly.
like in my journey, it was the soft skills, and it still is
Mm.
the soft skills. Knowing, like,
Yeah.
not even so, just knowing how to talk to people, and also myself, just being more firm and like standing my ground because
Mm-hmm.
I have the degree. I am a master's student.
Yeah.
I have the degree. So it's just stepping into what exactly I am because like imposter syndrome had me for a very long time. Like
Yeah.
I completely felt like no, this is clearly not for me. There's something wrong with me. But no, there's nothing wrong with me. So it's
Exactly.
changing my mindset that like the growth the what I've gone through is more of like personal development and growth on myself on my behalf as opposed to learning skills and all. I think technical skills, I don't think for me, for my journey personally, technical skills you can always teach them, you can always be taught, but
Mm.
it's who you become as a person
Yeah.
and looking for like the learning outcomes from it and not
Mm.
just saying, oh, no, it's me being a victim. Like, you can't have a victim mentality. You have to just,
Exactly. Yes.
yeah. So, yeah. So for me, my challenges were really with people, not, not anything else. Yeah.
Yeah.
But yeah.
But that's I have to agree with you. Working with people is not easy, but you can learn. Like you can learn how to do it. It's very difficult, but you can learn how to do it. And especially
Yeah.
if yeah, if you get to like other roles, project management, where you be having to work, even if you're not in project management, I mean, engineering is a team sport. You're gonna have to work with people. Yeah.
Yeah.
So that's something that you're just gonna have to learn how to do. Yeah,
Mm,
that's a similar challenge I face as well.
yeah.
I did go through that as well. Now onto the good stuff, the highlights.
um, highlights. Honestly, my main highlight was having the opportunity to actually graduate because my undergrad I didn't have a graduation because I finished in 2019, but my graduation ceremony was only in 2020. And can you imagine the day that was scheduled for my graduation was the day that lockdown was announced. So I didn't even
What?
have a chance. I didn't even have a chance. I'm serious. We had prepared, my family had prepared everything, flights, accommodation, and then nope, the university, the whole world is closed until further
Yeah.
notice. So honestly, just having the opportunity to have my family with me last year
Hmm.
in September, my birthday month actually, having them
Wow.
come and just shower me with love and
Yeah.
appreciation and all of that, that honestly has to be my highlight of just the end of my postgrad journey because at the end of it all, I was like, no, man, it just reaffirmed me. So that's really honestly like my main highlight. Other ones, yeah. But then it may seem very small to other people because I know there are people who don't even go to their graduation. But for me,
Mm,
I really appreciated that. It was really a
yeah.
milestone. Other highlights, I'm sorry, I just keep thinking that's like the main one. Other
That's the
highlights,
main
I
one.
think,
Mhm.
um, um, I think learning how to. Wow, my highlight is learning. Wow, but like learning how to read. I know, like but like um learning how to apply actual like experimental data into scientific like theories or models or all of that. I'm sorry, I just really like research. I'm sorry, but like
Yeah,
learning how to
I
do
get it.
that
I
was
get
something
it.
that
I
like
can see
actually
that
validating models.
you're the first person I have met that loves research. I have met and had a conversation with, honestly.
I just like it. So when I learned how to do it, I was like, oh wow. And I just kept on
Yeah,
trying to learn more about how to do that. But I'll still come back. We need to learn Python. We need to learn Python. I feel like it
deal.
would have made my life easier. It would have made my life easier. Um I really Oh, another highlight, but it's not necessarily linked to chemical engineering. So okay, maybe let me
Mhm.
not say that. Wait, let me not say that. Um, it's funny how we as people we focus on the challenges a lot, but then when it's like, oh, what are the good things that actually happened, and then you blank. Yeah,
Yeah, it's so
yeah.
true.
I'm like, oh, what are the good things?
The words were there when you're talking about the challenges.
Challenges, you can list them. You can list all of
Uh-huh.
them, but highlights, it's like, oh,
Where are
I
the
don't
good
know.
things?
I'm pretty
So
sure
I
there
think
are a
people,
lot more things that I'm
yeah,
not
yeah,
just not mentioning, but I think my main one was graduating after the journey
funny
that I
thing
had had.
is that, yeah.
Yeah.
And in the challenges that you have mentioned, is I see the highlights right there. I mean, with challenges you faced and finally being able to finish your MSc and having your parents in and your family in South Africa. I was wondering if you ever went since you started undergraduate, if you ever went back to Zimbabwe or you had to stay throughout until you finish your MSc in South Africa.
No. So at least Zim is close to South Africa. So I think in my undergrad I would go home every year. But then when I started, I think when COVID started, I think that's when I stopped going regularly. So but I always try to go every year. So if it's not December, it'll be maybe somewhere in the middle of the year. Or I remember last year, I went home specifically for my mom's birthday. I was like, okay, I need to
Hmm.
come home because I haven't done Christmas at home for like 2 years now.
Yeah.
So, but I mean, it just comes with adulting and growing. And but yeah, in my undergrad, I went home a lot. Yeah,
Okay.
a lot more often.
Right.
Yeah,
So for me, so I mean, I've learned so much. Like apart from
same.
the very, very technical things, some of them are past, but I'm sure this is going to be very helpful to the chemical engineers who understand all the technicalities about what you've talked about. But generally, I'm so grateful, Rufaro, for everything you've taken us through, for sharing your story, for sharing with us the knowledge you have. And what I've loved the most is that you share like something, the way you share it's so practical. Like you'll give a practical example or something that you have actually experienced, so it's practical to somebody. And that's the reason sometimes why I love having these talks. I mean, I could go online and research chemical engineers and where somebody can work, and then I come here and I present to somebody, and then it's just so dry, like what? And then but when you talk about it from experience, then it's now just full of life and somebody can relate to it. So I really do
Yeah.
appreciate you joining us at Uhandisi Talks. I mean, I've enjoyed myself. I have
No,
enjoyed
thank
myself.
you. Thank you.
Yeah, yeah. Do you have any parting shots?
Sorry?
Do you have any parting shots?
What's a parting shot? As
Parting
in,
shot is the like something to say at the end, like before we go.
oh, now you see, you put me on the spot there. I mean, what can I say? I think to all aspiring engineers, um, you can do it. Whatever you want to do, you can actually do it. You just need to set your mind to it. And even when things go wrong, it doesn't mean it's the end of the world. things going wrong isn't an indication of failure on your part. It's just, unfortunately, there are ups and downs that we cannot escape in life, unfortunately. But don't give up. Whatever goal or degree or anything that you are aspiring to achieve, just go for it and just give it your all. My mom always says, she would always say, like, after exams, okay, how was your exam? It was fine. It was okay, as long as you did your best. And I think that's something that I've carried out, like, even in my life. With everything that I do, I always make sure that I do my best so that I don't want to have any regrets or anything. So just do your best. And yeah, that's all.
Oh, that's perfect. That's a great thing. Honestly, yeah. As long as you do your best. Yeah.
Mm, mm.
Um, thank you so much, Rufaro. I really do
No,
appreciate
thank
you.
you.
I do
No,
appreciate.
thank you.
Thank you for not ghosting me on LinkedIn. Thank you for taking time. Thank you for taking
Mm.
time to join. Thank you for sharing your heart. Like, I felt like you've shared your heart. You just haven't been speaking to us. You've literally shared your heart out. So, to everybody who had joined us for this live, thank you so much for staying with us for 2 hours, 30 minutes. That's a long time. That's a long time. I mean, I'm just, I'm just hoping that you've learned at least one thing. There's sometimes that I learn one thing, just one, and it changes everything for me. It changes everything.
Mm-hmm.
I'm just hoping
Mm-hmm.
that you've learned at least one thing that is going to impact your life. Thank you so much for joining us. This is Uhandisi Talks. Thank you, Rufaro. I hope to see you again.
Thank
There's a
you.
lot that we need to work on and to work on Python. So I think we'll keep
Yes.
yeah. So if you have time, we'll keep having more of these discussions and collaborating. Yeah, I'm really it's
Yes.
been a pleasure. I don't know how to express it more than there, but it's really been a pleasure to have the discussion. Thank you very much. Thank you so much.
Thank you so
So that's it
much.
today.
Thank you. And
Yeah,
for this platform. Thank you so much.
yeah. Karibu. Karibu is, I'm so sorry. Karibu is Swahili. So here there is a language Swahili. So Karibu is you're
Mhm.
welcome. Yeah. So you're most
Ah,
welcome.
yes.
Yeah. Yeah.
Nice. Okay.
Yeah.
Thank you. Sure. Asante sana.
Oh, my lord, that's so good. You got it. That's it. Where did you learn that? I mean, you said it so well. Sure, like with the accent and
I knew
everything.
you would say
Almost,
that.
I mean, almost thought you're Kenyan already.
I get that a lot. No, I met East Africans during my undergrad. Yes, Kenyans, Tanzanians. Yeah. So unfortunately, I can't speak Swahili that well, but yeah, I remember that one. I remember Asante Sana. I remember Karibu.
Okay.
Yeah.
All right.
So
All
yeah.
right. Thank
Anyway,
you.
yes.
That's it for our viewers today. Feel free to put in the comment section what you've learned, some of the things that you'll need us to cover for our next topics, because this content is literally for you. So if we can tailor the content
Mm-hmm.
to what's touching you, then that's the only way we can make impact. Otherwise, we'll just be putting content out there that really doesn't help anybody. So feel free to type on the comment section, reach out to us. We have the email there. Whatever it is that you feel we need to discuss, we'll definitely research, get somebody to speak about it, and just share information that we need. That's all from us today. This is Uhandisi Talks, and my name is Barry Golder. Goodbye.